Hi all, I'm Angel and Alex. Today I'll be taking seminar on the topic Metaverse Technology. Today we'll be going through introduction, history, technological advances, applications of Metaverse, pros and cons, challenges, companies involved, conclusion and references. So imagine a place where many people from around the world can work, play, learn, and do many things together from their homes or from their comfort zone itself. For this is the Metaverse technology where all the above mentioned things will be possible. This seminar delves into some of the technologies that helps in the advancement of Metaverse. Next, we'll look into the history of Metaverse technology. In 1992, the word metaverse was first used in a novel, Snow Crash by Neil Stephenson. In 1998, Sportsvision aired the first NFL game using a yellow yard flag. In 2003, the online virtual 3D world called Second Life was released to allow people to create virtual worlds, interact with them, and virtual goods. In 2011, Ernst Klein created yet another vivid environment in Ready Player One. In 2014, Sony, Samsung, and Google all introduced VR headsets. In 2020, for MR and AR headsets, Apple incorporated LiDAR to iPhones. In 2021, Facebook officially changed its name to Meta to emphasize its contribution to the growth of Metaverse. We know that Metaverse technology is still going on and researches are going on, and many advancements have been done in the AR and VR technologies to make it more immersive. Next, we'll look into the technological advances. I have taken some of the technological advances, that is virtual reality and augmented reality, 3D reconstruction, artificial intelligence, and IoT. So, first we look into VR and AR. We know that VR and AR provides a 3D experience. VR makes objects appear to be real, making the user feel like they are immersed in their surroundings. AR transforms the actual environment with digital visuals and characters. These are some of the technical aspects of VR. The first one is a head mounted display. Head mounted display is a headset that users wear over their eyes. It typically consists of two screens, one for each eye, to create a stereoscopic 3D effect. The HMD may also include sensors for tracking head movement. Next is the tracking systems. To make the virtual environment respond to the user's movements, tracking systems are used. This includes positional tracking, that is, tracking the user's position in space, and orientation tracking, that is, tracking the user's head movements. Common tracking technologies include infrared sensors, accelerometers, gyroscopes, and external cameras. Next is the VR controllers. Most VR controllers come with a set of buttons, triggers, and typically a thumbstick that allow you to grab, push, throw, and move around virtual objects. The last one is the stereoscopic 3D rendering. VR relies on stereoscopic rendering, which means that two slightly different images are rendered, one for each eye, to create a 3D effect. This requires specialized rendering techniques and softwares. Next, these are some of the sensors that we have used. The first one is an accelerometer. It is used to measure acceleration forces including gravity and used to detect changes in velocity and orientation. They are commonly found in VR controllers and headsets to track movements and gestures. Next is gyroscopes. It measures angular velocity and are used to detect rotational movements. They are often used alongside accelerometers to track the orientation of VR devices accurately. Next one is infrared sensors. IR sensors such as photodiodes and phototransistors are used for tracking the position and orientation of VR devices that emit infrared light. These sensors are commonly used in optical tracking systems. The last one is a pressure sensor. Pressure sensors can be integrated into VR controllers to detect how much force a user is applying to buttons, triggers, or grips. This can provide feedback and improve the user's sense of emotion. The first picture shows HMD, and the second picture shows a person using VR controllers. Next is an architecture block diagram of AR system. First, the camera of a smartphone detects markers and takes 2D images from the actual world, serving as the AR system's input. Next is the AR Core. AR Core is Google's platform for building augmented reality experiences. Using different APIs, AR Core enables a phone to sense its environment, understand the world, and interact with information. In the capturing module, image and object capture are accomplished. Next is the tracking module. Here, the object is located by determining its direction and location. Next is a render module. This component describes how virtual elements will be added to, presented to, or combined with the original image. The results of augmented reality are then shown on the phone's screen. This is a picture showing AR versus VR experience. Uh, in AR, different people are using augmented reality on smartphones. And coming to the virtual reality, people using virtual reality glasses are shown. Next technology is 3D reconstruction. It is the process of creating a 3D model or representation of a physical object or environment from a set of 2D images, depth data, or point cloud information. For example, for medical uses, it is used with MRI equipment that allows medical professionals to see a 3D model of a brain without performing surgery. Another example is a 3D computer graphics for film to create more realistic images. This is a basic block diagram of 3D reconstruction. The first block is the input data. It can consist of images, depth data, or a combination of both. Next is the feature extraction. In this step, distinctive features or key points are extracted from the input data. These features serve as a reference points for matching corresponding points in different views. In matching features, the extracted features from different views or frames are matched to find corresponding points. Next is the triangulation. It is the process of determining 3D coordinates of points in the real world based on their 2D projections in multiple images. This is typically done using techniques like stereo vision, structure promotion, or multi-view geometry. In 3D point cloud, after triangulation, we obtain a 3D point cloud. A point cloud is a collection of 3D points that represent the positions of objects or surfaces in the 3D space. Next is the surface reconstruction. The point cloud is often noisy and sparse. Surface reconstruction techniques are used to generate a continuous 3D surface or mesh from the point cloud. Various algorithms such as matching cubes or Poisson reconstruction can be applied for this purpose. Next is the 3D model output. The final output of the 3D reconstruction process is a 3D model. This can be a mesh or another representation of the reconstructed scene or object. The 3D model can be used for visualization, analysis, simulation, or integration into various applications. Next is the artificial intelligence. We know that AI can analyze data quickly and can create metaverse avatars. AI algorithms can evaluate 2D and 3D photos to create lifelike avatars. This is the basic block diagram of AI. So let me explain this with an example. Let's say we want to build a spam email classifier. So the first block is input data. Here we collect a data set of emails, some labeled as spam and others as non-spam. In data processing, we clean and tokenize the emails, removing stop words and special characters. In feature extraction, we use technique like TF-IDF, that is term frequency inverse document frequency, to represent each email as a numerical vector. TF-IDF can be defined as the calculation of how relevant a word in a series is to a text. Next is the machine learning algorithms. Here we choose a machine learning algorithm like a support vector machine, that is SVM, or a deep learning model like a recurrent neural network RNN. In the model training, we train the model on the labeled data set of spam and non-spam emails. Next, we measure the model's accuracy, precision, recall, and its recall on a validation set to assess its performance. Next, we deploy the trained model in an email server to automatically classify incoming emails as spams or not. In the feedback loop, we continuously monitor the model's performance and retrain it periodically with new data to adapt to evolving email spam patterns. In the output, the deployed AI system classifies incoming emails as either spam or non-spam, helping users filter unwanted messages. Next is the Internet of Things. We know that IoT links our real world to the Internet via sensors and gadgets. Once a connection to the Internet is achieved, such devices are given a unique identifier and can automatically send or receive data. We'll see this with an application in healthcare. I have taken remote patient monitoring. First one is IoT medical devices. Patients use IoT-enabled medical devices to collect health data. These devices include wearable sensors like smartwatches, fitness trackers, etc., home monitoring devices for measuring vital signs such as blood pressure, temperature, etc. In data collection and transmission, the IoT devices or continuously or periodically collect health data and transmit it into a central hub or a cloud-based platform via wireless communication technology such as Wi-Fi, Bluetooth, etc. In data aggregation and storage, in the cloud or on a secure server, the collected data is aggregated and stored. For the data analysis and alerts, healthcare providers have access to collected data through a secure web or mobile application. Advanced analytics and machine learning algorithms can be used to analyze the data in real time. If the data falls outside predetermined thresholds, the system generates alerts. Next is the applications of Metaverse. Uh, some of its applications are gaming, education, retail, architecture, medicine, and healthcare. First one is gaming. Gaming plays a significant role in the development and application of Metaverse technology. Gaming enables social interaction. Gaming within the Metaverse facilitates social interaction. Players can connect, communicate, and collaborate with others. Next is the education. Metaverse platforms can host virtual classrooms that replicate the traditional classroom and environment. Students can gather in these digital spaces for lectures, discussions, and collaborative activities. Metaverse breaks down geographical barriers, enabling students and educators from around the world to connect and learn together. Next is the retail. Retail in Metaverse refers to the concept of conducting commercial activities such as buying and selling products and services within the virtual interconnected world of Metaverse. Metaverse technology can use AI and user data to offer highly personalized shopping experiences. Virtual assistants and recommendation algorithms can guide users to products and services that match their preferences and needs. In architecture, architects and designers can create and collaborate on architectural designs within virtual environments, enabling real-time 3D modeling, experimentation, and visualization of building concepts. Design teams, clients, and stakeholders can virtually tour architectural projects in 3D and VR, offering immersive way to review and provide feedback on designs, materials, and layouts. Next is the medicine and healthcare. First one is telemedicine and virtual clinics. Virtual healthcare consultations can be conducted within the metaverse, allowing patients to meet with healthcare providers, receive diagnosis, and discuss treatment options in a secure and immersive virtual environment. In remote monitoring, wearable devices and sensors can be integrated with the metaverse, enabling remote monitoring of patients, vital signs, health conditions, etc. This figure shows types of metaverse services. Next, we'll see the pros and cons of metaverse technology. While talking about the pros, it connects global communities. It dive into lifelike experiences. It also unleashes new opportunities for entrepreneurship and innovation. It makes more interactive and engaging online learning experiences. It takes gaming to the next heights. About consequences, cybercrime poses a significant risk in metaverse. There is a potential for negative impacts on cultures and societies. Privacy and security issues are also there. It loses connection with physical world and virtual bullying. Next are the challenges. Even though metaverse has numerous possibilities, it also comes with several challenges and concerns that need to be addressed. These are some of the key challenges. First one is privacy and security. As people spend more time in the metaverse, concerns about the collection and misuse of personal data, cyber attacks, and digital security become more important. Protecting users' privacy and ensuring their online safety will be a significant challenge. Next is the accessibility. To be inclusive, the metaverse must be made accessible to individuals with disabilities. This includes taking into account people who have cognitive, motor, auditory, or vision impairments. Interoperability. Users may find it difficult to transition between virtual worlds as a result of different metaverse platforms and technologies not working well together. Addiction and mental health. Spending excessive time in virtual worlds can have negative effects on mental health. Digital divide. Access to the metaverse relies on internet connectivity and access to capable devices. Bridging the digital divide to ensure that everyone has equal opportunities to participate is a challenge. Next is the digital identity. Creating and managing digital identities in the metaverse can be complex. Ensuring the authenticity of users' identities and preventing impersonation or identity theft will be critical. These are the companies that are involved in the research of this metaverse technology, that is Meta, Apple, Microsoft, Epic Games, Nvidia, and Roblox Corporation. So I have come to the end. In conclusion, Metaverse technology stands as a promising and rapidly evolving technology that has the potential to improve how we interact, socialize, work, and entertain ourselves in a virtual environment. As it continues to develop, it holds promise for a wide range of applications and opportunities. But it also raises important questions regarding privacy, security, and accessibility that must be addressed as it becomes an integral part of our digital future. These are the references I have taken for the seminar. Thank you.